So that is the why part of it. And now let's ask the question, where is AI or ML useful, right? So we'll talk about what is AI or ML. That's the goal of the workshop itself. But before that, we are asking why should we care about this? And now I just want to briefly talk about where is AI or ML applied, right? So it's a very applied technology. So we should know where is it applied. And for this, let's consider this prototypical human. I'm sure all of you know who this is. This is Einstein, of course. But why is his picture here? Well, the point I want to highlight here is that, think of this as a prototypical human being, and a human being has several evolved organs. The eye, for example, is a very evolved organ, right? So the eye, your human eye, has evolved over millions of years. And what capability does it have? Well, it can quickly identify objects. It can quickly identify who and what objects it's looking at, and it can react to reflex and so on and so forth, right? So it has several non-trivial capabilities. And now, one of the goals of artificial intelligence, and we'll talk about the word intelligence itself, is to mimic the human eye, right? So to mimic what a human does with his or her eye, can we make a computer do the same? In other words, can we make computers recognize objects, right? So if I give a picture to a computer, can the computer recognize, hey, there is a tree in this picture, hey, there is a human being in this picture, and so on and so forth, right? So this is sometimes called as the problem of computer vision. That is, you want to inculcate vision's capability to a computer, and that is part of the broader goal of artificial intelligence, right? So artificial because it's a computer that's trying to be intelligent. And what is intelligence? Well, one aspect of intelligence is to mimic the human eye. That's just one aspect. We'll see more now. Here is one more. Speech is another very evolved capability that human beings have, right? So early humans, maybe millions and millions of years ago, were communicating using sounds in the forests, right? So even still now, if you go to Africa, there are certain tribes which communicate only using sounds. And it's very basic rudimentary amount of communication. But then today we have so many different languages. We can write poetry, we can communicate complicated feelings and emotions using language, and so on and so forth. Now we ask the same question, right? So can we make a computer write poetry, for example, right? So can we make a computer understand text? Can we make a computer generate jokes? Can we make a computer detect sarcasm? So on and so forth, right? So there are so many so many possibilities that a human being's speech has provided him or her with. Can we ask the same question, right? So can we make a computer do these intelligent things that a human being does with their speech? The next thing is the text part of it. Text is, well, it is also language, but it is written, right? So now there are different questions here, right? So now people write differently. By that I don't just mean the handwriting difference. It is the semantic difference, right? So for example, if I want to express an idea, and I want to write a letter to express that idea, and I might express it in using a certain bunch of words which I am comfortable with. Now you might have the exact same idea, but then when you want to express it, you might express it differently, right? So but then if a human being reads these two letters, he or she would be able to say, well, it's the same idea that is being conveyed in both of these. On the other hand, this becomes a very non-trivial and challenging task for a computer, because because it's not easy to understand this using rules, right? So when I say rules, right, so if these bunch of words are put together, it means this. Well, as human beings, we have somehow developed that capability, but then we cannot kind of list down a rule for every set of bunch of words, because there are too many words that we have developed as in our language, right? So it becomes a non-trivial task for a computer to understand text. And if we want to develop a computer which is artificially intelligent, quote unquote, then we should provide the computer the ability to understand, parse, and basically understand text, right? So that's the capability that an artificially intelligent computer would have. Well, the holy grail or the biggest question here is to understand the human brain, because whether it is vision, whether it is language, whether it is text understanding, whatever it is, finally everything, the action happens in the human brain. Now a computer has its own equivalent of a brain, a memory, a processor, so on and so forth. But that's just rudimentary, right? So the human brain is too complicated. It makes several decisions, it takes several inputs, and then tries to make decision based on all these inputs and so on and so forth. And we use it every day, but we don't completely understand how it works, right? So that's the irony of it, right? So we have such a powerful engine in our heads, which is the human brain, but we don't exactly know how it works. Of course, we know a little bit, we know the basics of neuroscience has taught us a lot about how the human brain works, but to use that knowledge and enable a computer to act like a human being, a human brain, seems to be a task that is very challenging, and that is also part of a bigger scheme of developing an artificially intelligent computer. But this is not it, right? So this is just capabilities that a human has that we want a computer to achieve. But when we broadly say the term artificial intelligence, it's not just these capabilities, right? So there are other places where artificial intelligence could be applied, and these are several places, right? So for example, you might have biological experiments where you might have DNAs and gene sequences and whatnot, and you want to analyze that using a computer to extract meaningful patterns from it, right? So we'll talk more about extracting patterns and so on as we go along, but that is one application where artificial intelligence is used a lot. Another could be in finance. You might have stock markets. If you have heard about stocks, stock prices fluctuate every single day based on different market factors and different political situations around the world, etc., etc. And now, can we track how the market fluctuates, and can we predict tomorrow if a particular stock will go up or go down, right? So, and why is that useful? That's useful because if a stock's price will go up tomorrow, then I might actually buy that stock at a lower price, and it will go up tomorrow, and so I end up making some amount of money there, right? So stock market prediction is another thing where a lot of data is involved, and you can build and hopefully an intelligent system that can find patterns in how market is fluctuating and then react according to it and make buy or sell decisions. One more example, again these examples are not exhaustive, these are just some examples that I am throwing at you just to give you an idea of how broad this field that we are talking about is. Third example would be maybe chemoinformatics. This is you want to know how elements or compounds would react when they come when they are put together, right? So of course chemistry tells us how certain reactions have to happen and so on and so forth. But there are too many compounds and elements, and if you don't know, you cannot ask the question, you cannot do a laboratory test for all possible combinations, and so let's say if you want certain properties that a material should have, maybe you ask a computer to somehow suggest you what are the most likely way things should be combined so that a material that comes out of it has a certain interesting property, maybe property like hardness, brittleness, and so on and so forth, right? And now by knowing some earlier properties of some materials, can we predict new materials with new properties and so on. This is another material informatics or applications of artificial intelligence to chemistry. Some more interesting examples. Sports is another example, right? So if you follow cricket you know, let's say you are an IPL fan, and you want to know, you know, tomorrow two teams are playing against each other. Let's say I'll pick my two favorite teams. Let's say CSK, Chennai Super Kings, and RCB, Royal Challengers Bangalore. These two teams are playing against each other, and I want to know who will win this game tomorrow. I know who are the players who might be playing, and I want to predict who will win tomorrow, right? So, and RCB and CSK have played several matches before with different bunch of players, and now a new set of players are going to play. Well, some of them, you know, have played earlier, some of them perhaps new, and now can I make a prediction as to how much runs will CSK score or how much runs will RCB score, right? Well, so that is sports analytics. That's a whole field called sports analytics, and that's not just predicting, you know, winners of games. You might want to predict, you know, as a batsman. Let's say if you are a cricketer and you are facing a bowler, let's say like Bumrah, and you know there is certain situation right now in the scoreboard, and you want to know, you know, whether he's going to bowl a bouncer or a Yorker, right? So these are two different types of deliveries that one can bowl. For those who are not well versed in cricket, the details don't matter. But what I'm trying to say is, you know, can we figure out, right? So can we predict what is the most likely delivery that Bumrah would bowl in this particular situation? If I know that as a batsman, then I can perhaps use that to play better cricket, let's say, right? So that's just another example of where AI can be used. And this is something that most of you might have already you know, experienced. So this is e-commerce. Let's say your parents buy or you place an order in, let's say, Amazon or Flipkart, or whatever your favorite e-commerce site is. You know, when you go and look for certain product, you also get some recommendations along with it, right? So maybe you're looking for a laptop, let's say, and then you might get recommendations with respect to you know, I don't know, USB drives or something like that, right? So some related things which you might be convinced to buy along with the laptop as well, right? So because the e-commerce site is of course trying to make sure that you buy as many things as possible so that they can make money, so they will have to recommend the right things so that it's useful to you, so that you will make a decision to buy, so that they make the money, right? So now how can they know what you are thinking, right? So or what might be interesting to you, right? So now that is a problem of artificial intelligence or data science, because they have a lot of data as to who bought what and how, and then they want to use this information to make you buy a certain extra thing other than the one that you're looking for as well, right? So that might be a e-commerce application of data science and AI. So again, these are not exhaustive. I just gave you some examples just to illustrate that, you know, the applications of AI are far and wide. Now here is a simple question for you to think about. Doesn't matter which branch you are studying right now. It could be computer science, it could be economics, it could be biology, it could be anything. Now pause this video and think about some potential application of AI just from whatever we have discussed so far that you think might apply to, you know, the area of your current study, right? So whether it is in computer science or biology or economics or anything else, right? So or even if it is law or anything else, right? So think about, from your current understanding, from whatever we have discussed, think about one application where you think AI could be useful. You can pause and think. We will now proceed to the next slide.